Hello everyone, thanks for tuning into today's video, the first of today's video. I'm also going to be doing the summer forecast later on today, the second one, so we'll come back for that a little bit later on. But thanks for tuning into the first video today. I'm doing the answers to Ask Gav. Last Sunday I brought back Ask Gav, and I've been getting your questions through the comment box at gavsweatherviz.com. I've been posting some really interesting questions, very challenging, some of those questions, and very involved, but really interesting questions, and thank you so much for doing that. Thanks for embracing Ask Gav and giving me some questions to ponder, or some questions to answer, perhaps I should say, and thanks very much for doing that. We're going to be doing the answers today. Now, before we go on, I just want to talk about the advertising. There'll usually be ads on my web pages. You can click on those ads and go through to the advertiser. If you're interested in the ad, please do that. And there may be video ads as well on my with my videos, and please pay those ads. You'll be supporting gavsweatherviz.com by doing that. So as I say, I've had some really interesting questions, and I'm going to be looking at those questions through the course of this video, attempting to answer them. I'll be using a few websites to answer some of those questions. Not all of the questions are going to be answered by using websites, so I'm just going to run through them and answer the questions that I can before I go off to the websites to answer some of the other questions. Now, I've printed out your questions, so I hope you don't mind if I just look down at paper and quickly read out those questions, and then I'll give you the answers. So the first question comes from 10TedW, and 10TedW wanted to know what the effect of global warming could be for the United Kingdom. Well, I don't really talk about global warming very much. There's a very good reason for that, and I always say if people ask me about it, really it's above my pay grade. I try to keep the website and my own personal views away from the whole global warming, climate change conundrum. There's a lot of other websites out there that do a lot on global warming and climate change. A lot of forecasters that are very interested, may have some very strong opinions about it. I try to keep away from the controversy as much as I possibly can, but I would say that obviously the trend has been for warming to take place really since the end of the Little Ice Age. We've been warming up very gradually. The warming accelerated in the second half of the 20th century. All the scientists say that, or most of the scientists say that this is down to putting carbon into the atmosphere. And it's not for me to really to say that those scientists are wrong. So if they're right, you would suggest that the trend is going to be over a long period for temperatures to increase. But what I would say about this is that we've got some very interesting conditions going on in the sun. Just at the moment, the solar cycles are very, very weak, and that could well offset the climate change trend quite a bit. And I'll be talking a little bit more about solar activity later on in the video. It's very specific to the United Kingdom and to Northern Europe, but weak solar activity does correspond to blocking, particularly in the winter, and that gives us colder weather. So whilst the rest of the world could well be warming up over the next, say, 30-50 years, we may find a localised cooling taking place in the Northern Hemisphere, particularly around Britain and Northern Europe, where that blocking in the winter is very pronounced when you get weak solar cycles. But I'll be talking about a little more about it a little bit later on in the video. Now, the next question comes from Darius. Darius wanted to know basically why snow happens more on high ground that's around the top of the valley, as opposed to high ground generally. So over mountainous regions you tend to get more snow on high ground at the top of the valley than you do over continuous areas of high ground. And for that I'd say that really it's down to the fact that when you get continuous mountains, you tend to break up a lot of the cloud that produces the precipitation. A lot of that cloud does get broken up by the mountains, and so the precipitation isn't as heavy. Whereas if you've got just a single area of high ground in a valley, there's nothing really to break that cloud up. Often the high ground won't go as far up as the cloud base anyway, so the snow falls down onto that area. But when you've got a continuous, say, mountain range, you do tend to find the cloud being broken up quite a lot by those mountains. And of course, it's always drier on the other side of the mountain, on the eastern side of the mountain, as opposed to the western side of the mountain, where the precipitation is coming through. Or if winds are coming from the east, if precipitation is coming from the east, as it does tend to with snow, then you have it more on the eastern side of the mountain range, but you will on the western side of the mountain range. But I would say that's the reason why you tend to get more snow on just one area of mountainous regions and a valley, as opposed to a continuous area of high ground or mountains. Now, Antonio Pachawaka, I hope I pronounced that correctly, Antonio, wanted to know what would happen if a jet stream split in two, with one area of the jet stream going to the north of the country and one area going to the south of the country. Basically, that happens quite a lot, actually, Antonio, and you'll get an area of high pressure forming when that happens. That's one of the key factors in forming an area of high pressure, to be honest, that you'll split the jet stream, send a branch off to the north, send a branch off into France, and you'll tend to get an area of high pressure then blocking over the British Isles, or somewhere around northwestern Europe, I should say. So that does happen quite a lot. It's quite a common occurrence, actually, to split the jet stream through the Atlantic and send one area to the north, one area to the south, with high pressure forming in the middle of that split. Paul wanted to know, when blocking highs blow around an area of high pressure, when you get easterly winds blowing around an area of high pressure over Russia, when does the temperature start to, or the air start to become warm and start to become cold? Well, there's no real period for this, Paul. There's no definite answer to this, but I would say that an area of high pressure from Russia, easterly winds from Russia, would tend to give you warmer weather any time from around April onwards, really. And again, it's the same for winter. Any time the cold air would be any time from around October onwards. But to be honest, there's no definite answer to this question. It just depends what the air is doing across Russia and across Europe, where that easterly wind is coming from at any given time. So you could have an unusually cold pool of air somewhere across Europe in May, for instance, and you might get a very cold easterly wind, whereas another year you might have an unusually warm area of air that's come out of the Mediterranean in May somewhere across Central Europe, and that may give you a much warmer spell of weather. So there's no definite answer to this question, but October probably start getting cold air coming in from the east. April start getting warm air coming in from the east is probably about right, but as I said, there's no definite answer to that one. John from Lincolnshire wanted to know about the thermometer and feels like temperatures. The feels like temperatures, but the BBC have been talking about through this winter is indeed wind chill. And wind chill is based on the actual air temperature combined with the strength of the wind. And yes, wind chill is very important. John wonders whether it would be more useful to talk about wind chill more than the actual temperature. And probably in the winter there's quite a good argument for doing that, to be honest. I probably don't do it as much as I ought to in my weather videos, but yeah, I would say that wind chill could well be more important than the actual temperature in the winter. It's less important through the summer, of course, but the main thing in the summer is the actual temperature, because it gets very, very high. Then you get all the heat and humidity going on. But in the winter, yes, feels like temperatures, wind chill temperatures, probably a little bit more important than the actual temperature. Kazim, one of my long-time followers and good friends, one of my Twitter followers as well, and I follow Kazim. He's an excellent forecaster, just starting out. He wants to know about long-range forecasts. Why are they all over the place? And do the Met Office and BBC bias towards their own long-range output? Well, Kazim, it's not for me to say about BBC and Met Office weather forecasts. I just get on with my own thing. I'm not really sure what the BBC and the Met Office do in terms terms of their long-range forecast. But they're very good at whatever it is they do. They do some really quite good long-range forecasts, but it really isn't me to comment on what they are doing at BC and Met Office. And in terms of the long-range forecasting, why are they all over the place? Well, long-range forecasting is just so difficult to do. The seasonal models are about the best we've got, but they're still in their infancy. The science is still very much in its infancy. I use the seasonal models in the hope that I'll be able to help drive forward the reliability of those models if we all start using the seasonal models and talking about them, examining them, and coming back at the end of the forecast and seeing how well they've done. Then eventually we're going to start to drive forward the quality of those models, because the agencies that have those long-range models will improve the computer power, and the reliability will improve. So I use the seasonal models hopefully to help drive forward the trend. But it's cutting edge stuff. It's pushing the envelope really with those seasonal models, and really the reason for this is the chaos theory. It's as simple as that. The butterfly flaps its wings in Australia, it forms hurricane 2 or 3 weeks down the line in the Atlantic. That's the chaos theory, and the seasonal models just can't pick up on these on this theory really. The seasonal models have very good computer power. They are inputted with a lot of data, but ultimately the weather is random. And beyond a certain set period, the computer models are just picking up on little bits of trends and trying to run with the idea. But you'll always have the chaos theory just there, holding back what the computer models can do. And really, as simple as that. It's just the way the atmosphere and the weather is set up. Now I'm going to take the next 2 questions together. Gunnar wanted to know, do I think that this year could be a very blocked year? Do I think we could see more blocking going on over the next 12 months, over the whole of the 12 months of the year, 2013 making a cold year? And Kieran wanted to know what my gut feeling is for the summer. Well, Kieran, I'm going to give you a little sneak peek here at the Brazilian 500 millibar height anomaly that you're going to be seeing later on in the summer forecast. And this is it. The Brazilian model is predicting a large extensive area of blocking to the north of the British Isles through the course of the summer, with the jet stream tracking underneath. That's a very poor 500 millibar height anomaly. Those blue areas there are above average heights, high pressure to the north of the country. That's a very, very poor anomaly, with the weather systems going underneath that blocking area of high pressure. And yes, I do think that this year could well be a very blocked sort of year. I do think that we could well see further blocking throughout the year, and as we get on towards the autumn and into the winter, I think some of that blocking could well give us some quite cold conditions, to be honest, as we go into the autumn. So my hunch would be that we'll continue to see further blocking throughout the year. Matthew Alder wanted to know what was the coldest year since 1600, from January through to December, and what year was had the coldest average summer temperature. So we're going to go to Hadley and have a look at the Central England temperature, and this year that I've highlighted here is in fact the coldest year in the CET index. It's 1740. It had a yearly Central England temperature of just 6.84. It was a ferociously, horribly cold winter in 1740. We had a temperature there in January minus 2.8, in February minus 1.6. It was a horrendously cold winter, and unusually, perhaps the cold just continued through the year. So March had a central temperature of 3.9, April 6.4, and so it goes on month after month after month below average. August there just 14.7. September wasn't too bad, 14.0. That's quite good for September, but it was the only month really throughout the whole year to have temperatures that you could regard as being average or maybe a little bit above average. Every other month throughout that whole year was cold. And indeed 1740, as I say, is the coldest year in the CET index, with a central temperature for the year of 6.84. For summer, it's hard to pin down which summer was actually the very coldest, but this one in 1816 was really quite cold indeed. Here we go. It was a very poor summer. Had May central temperature of 9.9, June 12.8, July 13.4, terrible July central temperature that, August 13.9, and September 11.8, a really horrible cold extended summer. And the reason for that was the eruption of Mount Tambora that happened the year earlier in 1815. It happened in April 1815, and it was a terrible eruption, probably the worst volcanic eruption in recorded history. It blanketed the whole of the earth in sulphur, and that was the reason that we had that terrible year without a summer in 1816. It rained, it poured, there was famine, there was disease, terrible typhoid outbreaks across most of Europe, terrible famines across most of Europe, and it just poured with rain and was cold and wet and dull. And it certainly, this does put into perspective the last few summers, because we all think that we've had some very poor summers. Indeed, we have had some really quite poor summers, but that summer in 1816 does put things into perspective and shows you just how terrible the summers can get in this country in the right conditions. But that eruption from Mount Tambora in Sambora, I should say, was really quite unusual, and we don't see those sort of volcanic eruptions very often. But if it happens, it just goes to show you how cold and wet it can get in a British summer. Now, Bob wanted to know what my thoughts are for winter, for next winter, and he also wanted to know which year was the coldest and snowiest, or which winter was the coldest and snowiest since 2010. And finally, Collie wanted to know about, with the low sun solar cycle activity, with solar cycle 24 being very weak, solar cycle 25 being very weak, whether I thought we could be heading into another little ice age. So the next website I want to look at is solarham.net. This is the current position of the sun, and again we're seeing very weak solar activity here across the solar disk. We are now at solar maximum, and the solar cycle continues to be very weak, very low solar cycle. So Bob, I would say that with this solar cycle being so weak, there will be an ongoing risk of a cold winter next winter. Now, that's not to say that next winter will be very cold. The winter of 2013-14 will be a cold winter. It's not. I'm not saying that, but I'm saying that with solar activity continuing to be weak, it increases the risk of blocking across Northern Europe. We know this is correct. It increases the risk of blocking. And yes, there will be an ongoing risk next winter and the winters beyond as we go towards the solar minimum. We haven't had much of a solar maximum, but we're virtually at it. We're going into solar minimum over the next 5 or 6 years. There'll be an ongoing risk throughout that period of colder winters as we go back into solar minimum. And in terms of the winter, yes, it was 2009-2010 was the coldest winter that we've had since 2000. It's actually the coldest winter since 1979. Of course, we had that severely cold December 2010, the winter of 10-11, but then it turned milder that winter, so actually February 2011 was quite mild. So overall, winter of 2009-2010 was the coldest winter for a long time, and it's also the snowiest as well. And Colin, in terms of cycle 24 and 25, whether I think there's going to be a little ice age, I've got to say, again, it's really is against my pay grade. Presumably, but climate change, the warming, will offset this a little bit, and we probably won't get a little ice age. But who knows? Who knows what the future holds? It may be that the sun is the key player, and the sun is going to become very weak over the next few solar cycles, and we will go into a little ice age. I can't say. The fact of the matter is, I don't know. And if I was to give you a definitive answer about this, I'd be misleading you. I don't know what the future holds, but it does look as though solar cycle 24 is going to be the weakest cycle for over 100 years. It's very, very probable that cycle 25 is going to be weaker, or going to be as weak, maybe weaker. There'll be an ongoing risk with this over the next 10, maybe 20, 30 years. I think there's going to be an ongoing and increased risk that we're going to get cold winters at the very least, because we know, as I explained, and this will take us back to where we started off at the video really, we know that weak solar activities coincides. The reason for it isn't that clearly understood, the mechanism, but we know that somehow weak solar activity seems to coincide with the jet stream weakening and blocking becoming more of a player, particularly for Europe. Blocking in winter means that it will get cold, and even if you warm things up by a couple of degrees, nevertheless, if you get a lot of blocking, as we've seen with December 2010, we saw it again with March, just gone, March 2013, you get a lot of blocking over an extended period and you tap into Arctic origin air, it will get severely cold, even in a warming trend. So that's my prediction. I think we're going to see more cold winters over the next few years, certainly in comparison to what we've had in the 1990s. More cold winters. Whilst I wouldn't go as far as say we're going to have a little ice age, I think the future is certainly looking colder, particularly in winter over the next few years, even with the warming trend of global warming / climate change. Well, that's it. I hope you've enjoyed the answers. I hope I've answered your questions satisfactorily. I hope you found the video interesting and informative. Come back later on for the summer forecast, the second summer seasonal model roundup. That's it for now, though. Thanks for watching, and thanks so much again for giving me your questions to answer. That's it for now.